Good day, everyone. Um, Thank you for joining today's class. Because of our time, like I promised, we need to quickly talk about set theory. And the set theory will just give us the tips. I'll share my slide now using the course materials, and from then I will explain some of the examples. Then from then we'll solve some of the problems, especially that the one that you think you are not comfortable with, and from there we will also look into permutation and combination, and before we end up in the other topics. So let's move on without wasting much of our time. Let me share my screen. I welcome you once again. So here we go. Shegun Oka is my name, and today we'll be talking about set theory. I believe you can see my screen. So the basic things we need to cover in this unit is to know the definition of the set, the basic definition, the basic concept of set theory. Define the set theory, define the set of definition of set, basic concept of set theory, and operation involved in the set theory, the union set, intersection set, Venn diagram, and the use of Venn diagram and conclusion. So without much ado, a set is a collection of definite, distinct objects called elements. Definite, distinct object called element. Please don't forget this. Elements, or a member of a set. For the theory, for the set theory, it can be the set theory can be written in the capital letter. That is, when you're talking about set, you use capital letter, while the element always writes in lowercase, that is small letter. For example, if I have a set of A now, I can say I have a set of A. What are the elements in set of A? I, A, O, O, that is using the elements, using the set representation. For example, you cannot represent the set in this form alone without putting the brace brackets. These brace brackets make it distinct, make it known that we are talking about set theory. We are talking about a set. So if you are writing it this way, we say A is equals to 1, 2, 3, 4. This is not a good representation of a set theory. Please let's take note of that. That's the notation is very important. It's very simple. All you need to do is just to write a brace bracket. A brace bracket. So in a brace bracket, it represents a set. A set. So let's move on. Yes, we have different definition of or the basic. So when we're talking about unit set, is a set with only one element. For example, if I said the one element can be that B is equals to set J, meaning that's a unit set. It can also be A equals to 1, that's a unit set, and so on and so forth. So it can be elements, it can be alphabets, it can be figure. So take notes, that's a unit set. Some other people call it singleton set. So now we have that's by number one. Number two is non-set. Non-set is a set contain no element. It contains no element. When you have, let's say, set J can be element, can be this, can be empty, or we also represent it at times, this figure. We use this sign to represent set, but don't put it this way. Don't just write and put it this way. No, It simply means it contains something. So it must be, is either empties or you use the sign. Either this or you use this. Don't put the two together. This is not correct. Please take note of that. That's what we call a non-set, or a set that contain no element. Now, when we're talking about universal sets, a universal set that contain all the elements in a study or in given discussion. For example, when we are talking about gender, or when we are talking about, you can be talking about sex of human. So we know sex of human can be S equals to male or female, probably. They can represent it this way. So in this case, don't put, just use comma to separate them. That's the total universe in the sex of woman, like example in our book. And a universal set also can be the total alphabet, total numbers of alphabet we have, A, B, C, D, E, F, till Z. It can be total number of alphabets. It can be like that. Or a particular set given to you. Or a particular set given to you. So if I said, for example, I can give you, if I give you 1 to 10, if I give you 1 to 10, if I give you 1 to 10, if I said set A is equals to, if I said universal set, I was representing the form of this: 1, 2, 3, 4, 5. This is my total set. This is my universal set in this case. So this is what I gave you as a universal set. Now, if I give you this, I can now ask you, this is a universal set of I can ask you to define it. I can ask you to bring some set out of it. So, for example, it now leads us to subset. A subset, set A is a subset of B. If and only if every element in A is contained in B. Set A is a subset of B if and only if every element in A is contained in B. All sets are subset of universal sets. A null set is also a subset of all sets. For example, I gave you this. Okay, let's look at this. We have A to be A, E, I, O, U. Now, and I have B is equals to A, B, D, E, G, I, B, G, I, J, M, O, P, U, R. So I have this. So when we're talking about subset, it simply means, look at A now. Everything in A, I can also get it in B. B itself, it contains everything in A. For example, we have A here, A is here, it contains here, E is here, E is here, I is here, we can get A here, we can get O here, O is also here, U is here, and U is also here. So it's meaning that A is a subset of B. That is, B contains more sets, more elements than A. and all the elements in A are also in B, are contained in B, using that word contain, meaning it accommodates, it also there. It's a big set. So people call, so we can continue from there. So meaning that we have also what we call equal set. Equal sets, set A and B are equal if and only if they contain same element. Please take note. Then we have a complement set, a complement of a set. A complement of a set are, they said, the complement of the set A designated of A prime. They call it A prime, or some people represent it A complement. Please take note. Is a set consisting all elements in the universal set that are not in A. For example, if I have universal set, like I said the other time, I have universal set. My universal set, excuse me, let's say my universal set is 1 to 5, this particular one. And I have, let's say, okay, let me call it A. A is equals to 2, 4, 5. So what is my A prime? Excuse me. What is my A prime in this case? A prime would what? Look at the definition. Universal set is what? That is, elements in universal set that are not in A, they are the A prime. So what are the elements that is universal set? Our U is 1, 2, 3, 4, 5. Then and I have set A from universal set, and I want complement, that is what make it a universal set. The remaining element will be A complement. Will be, what is the remaining element? 1 and 3. So if you add everything together, it will turn back to universal set. Please let's take note of all these definitions. They are very key. So let's look at the union. I will be using example to explain some of those things. We have what we call a union of a set, and we can look for the definition of the union of a set. The union in this case can be A union, this is the sign B. This is the sign for union, which is the same thing as number of A plus number of B, as in the definition way. That is number of A, number of B. Sorry for the typographical error from your book. I think I can clean some here. Let me just try and clean them so that we can enjoy it. Okay, sorry for taking your time. Okay, let's move on. Number of A minus intersection of A, number of A intersection B. Number of A minus. Sorry for the interruption. Let me continue sharing my screen. Okay, the definition is A union B is equals to the number of A plus number of B minus number of A intersection B. So let's take note of that. So I will use the question to explain some of the problem. Okay, let's look at the question. So from there, you'll be able to solve some of the problem in the book too. Okay, let's look at the question one. Question one says, let U universal set be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and define your A to be 3, 4, 5, 6, 7. And define our B to be set B to be 1, 5, 7, 9. Define our C to be 3, 6, 9. 3, 6, 9. Then we have D to be 2, 4, 6, 8. So we have this. Now the question says find Roman figure 1, A union B. Roman figure 2, A union B or prime. Roman figure 3, A prime intersection C prime. Intersection is the sense that the common elements among them, while the union means the union between them without repeating any other element twice. So when you are adding the set together, that's the union between the two people without repeating it other elements twice. So Roman figure 4, we have A union B and intersection C. Roman figure 5, A intersection C. Roman figure 6, B intersection C. Roman figure 7, A intersection C union B intersection C. Roman figure 8, B intersection D. Roman figure 9, B intersection D prime. But Roman figure 10, we have A minus D. That is the difference, meaning that element in A but not in D. That is A minus D. Then Roman figure 11, is B minus D. Roman figure 12, 1 equal 12 is A minus D union B minus D. 1 equal 13 is A union B minus D. Meaning that B minus D is the same thing as element in B, but not in D. Please take notes. Okay, now that we are here now, these are the questions we are asked to solve from these unions, from this universal set. How do we go about it? It's very simple solution. By the time we finish this question, all you need to do is, first of all, you know the elements A, B, the set A, B, C, D, E. You need to look for their complement first, because we know the universal set. Let's look for the complement. The complement for the first thing is complement of A. Let's look at the A complement. That is the element in the universal set, the element in A, the element in universal set that is not in A will be the complement of A. That is, we have the A complement set A is 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. What are the elements in them? So we need to look for their elements and put it in the right place. 3, 4, 5, 6, 7. The complement will be the missing element that is in the universal set. 1 is there, 2, 8, 9, and 10. They are the complement of A. So let's look at the complement of B. B complement also will be the element in the universal set, the element in B, that is sum of the missing element in B that is in the universal set. So will be 2, 3, 4, 6, 8, 10. They are in universal set. Let's look for the C. The one of C prime will be, that is C complement, will be 1, 2, 4, 5, 7, 8. Then the D complement also will be, D complement will be 1, 3, 5, 7, 9, 10. So the first thing we need to solve is to solve for A union B. A union B. So, okay, let's look at the first question. Oh, the first question actually is A union B. We have, okay, let's do the A intersection B first. Let me add another question. We have A union B. Okay, let me just solve this first. Let me call this one number 1. A intersection B. So that it will help us to solve some of the other problems. So A intersection B will be, that is, let's go to the B, A. What are the elements that is common from A and B? The common elements, let me use another pen here. So let's look at the common. We have 1 here. Do we have 1 here? No. We have 5 here. Do we have 5 here? Yes. 5, 5. We have 7 here. Do we have 7 here? Yes. 7 is here. We have 9 here. Do we have 9? No. So we have 5 and 7. They are the common elements here. So we put it in their bracket. We have 5, comma, comma 7. So I've changed the order now. A union B. Another question now. A union B will now be, let's check. What's A union B is add all the elements together, all the two sets, add them together without repeating any element twice. Although the element can appear twice, but you only pick one. That is the meaning. So let's look at it. We have 1, 3. We have 1, 3, 4, 5. Yes, 6, 7, and 9. That's what. Yes, 5 appear twice. Just pick one. 7 appear twice. Just pick one. I hope you get the point now. So let's continue. Let's write the answer they set out. 1, 3, 4, 5, 6, 7, 9. Correct. So number 3. The third one will be, in this case now, we have A union B prime. A union B prime. A union B prime. So for A union B prime, what do we need? Let's go to union. Yes, we look at the question 2 now. That is, A union B is here. We have it here. So how do we get the complement of the entire number 2? It's very simple. All the elements present now in number 2, look at them. We have 1, 3, 4, 5, 6, 7, 9. So we will go to universal sets. That is, we'll compare it with universal set. The universal set is here. So any element in universal set that is not in A union B will be the complement of A union B. So let's look at them. So 2 is not here, and it's a universal set. Yes. 8 is not here, and it's a universal set, and 10 is not here as a universal set. These are the complements. So number 4, A prime intersection C prime will be A prime. Let's go to the A prime. We've done that. We have A prime here. We have C prime here. What are the common elements between the two? A prime intersection C prime. So let's look at them. We have 1, 1, 2, 2. We have 8, 8. What else do we have in common? 9 is not there. 10 is not there. So we have 1, 2, 8 in common. So 1, 2, 8. These are the intersection between them. So number 5, or any number you call it, A union B, then intersection C. A union B intersection C. So let's go there. What is A union B? We have A union B is number 2, don't forget. Now intersect it with C. Go to the element C, set C rather. So set C is here. What are the things in common? We have 3 here. Do we have 3 here? Yes, 3 is there. Then we also have 6 here. We have 3. So what do we have in A union B? So 3 is also here. Then we have 6 also. 6 is also here. Then we have 9. 9 is also here. Meaning that we can write it 3, 6, 9. So that settled it. So it's simple and it is very technical. If you don't follow the steps, if you don't solve one correctly, you might miss all. So please, let's be patient when we are doing the set theory. So we have A intersection C. A intersection C. Let's go to A intersection C. We have A here. 3 is here. 3 is also here. 6 is here. 6 is also here. We have 9 here. We have 9. No. So we have 3 and 6 that are common to them. 3 and 6 that are common to them. So 3, 6 are common to them. So we have here 7. B intersection C. B intersection C. Go to B and C. What is common to them? B intersection C. Do you have anything? You have 3 here, no 3 here. Do you have 6 here? No 6 here. Do we have this? Oh, we have 9. 9 is there. 9 is common to both sides. So 9 is here. Remember, when we are doing the definition, what do we call a single set? A singleton is a unit set here. So please take note of that. Number 8. We have here A intersection C and union B intersection C, which is very simple. So what is A intersection C? We have them in number 6. What is B intersection C? We have them in number 7. So the answer, we should add them together, which union means addition without repeating any element twice. So we have it 3, 6, 9. That's all. So number 9. So we have B intersection D. Let's go to B at intersection D. B intersection D. This is our B. We have B here, we have D here. Is there anything intersect them? 1, do we have 1? No. 5, do we have 5? No. 7, do we have 7? No. 9, do we have 9? No. Meaning it's empty set. There's nothing that is putting them together. We have it to be empty sets. Or you represent it in this way, empty set. Please take note. Number 10. So we have B intersection D all prime. That is, anytime you see prime of this, we're talking about the entire universal set. So, but B intersection B prime, you remember B intersection D is empty. Meaning, if you are looking for the complement of the empty, it will be the entire universal set. So we call 2, 3, 4, 5, 6, 7, 8, 9, and 10. So please take note of that. Number 11. So now, in this case, now we have A minus D. We need to be careful here. A minus D is the same thing as like the definition I gave us earlier on. Element in A but not in D. Let's go there. Element in A but not in D. This is element in A, but they are not in D. So what are the elements in A that are not in D? Let's check. A has 3. Does D have 3? No. Does not have D. Then A has 4. D also has 4. A has 5. there's no 5 here. A has 6, D has 6. A has 7, there's no 7 here. So the answer will be 3, 5, 7. So let's take note of that. 3, 5, 7. So then we'll do B minus D, that is element in B that is not in D. B and D. So element in B that is not in D. Element in B that is not in D. 1 is in B and not in D. 5 is in B but not in D. 7 is in B but not in D. 9 is in B but not in D. So we repeat the same thing. So it's going to be 1, 3, 5, 7, 9. So number 13 will now be A minus D union B minus D. That is, we need to find the union between 11 and 12. So 11 and 12 will be, the answer will now be, which is equals to A union. So will be, add everything together without repeating it twice. 1, 3, 5, 7, and 9. So you add everything together. But 3 is here, 3 is also there. 5 is here, 5 is also there. 7 is there, 7 is also there. Add everything together. Number 14 will be A union B. A union B minus D. That is, element in A union B that is not in D. So elements A union B that is not in D. A union B is here, number 2. And the element that is not in D, let's check. So those elements that are not in D will be 1, 3, 5, 7, and 9. If you check your question very well, if you take it very well, you will see that these are the elements they are talking about. So this is the first part of the set theory, and I believe any question you see from now on, you should be able to solve them without hesitating. So we've discussed about the union set, singularity set. We've discussed about intersection. We've discussed about different sets. We've discussed about union sets. We've discussed about complements, and we should be able to solve as many problems as possible that comes on our way. So now let's look at another example from our material. So from there, we will also look into, stop sharing here. So from here now, we will look into the word problem, some of the word problem examples that is in our book. And from there, we will also continue and solve the example again and look into different opportunity. So let's look at it. Let's go there. So we have it here. Now, let's look at this question. The question here is pretty simple. little typographical error, but I will try and make amendments along the line based on the experience. Now, the example says there are 3 factories: factory J, factory K. We have factory J, factory K, and factory L, supplying goods to a warehouse A. They supply goods to warehouse A, warehouse B, warehouse C. So, and D here. So the amount supplied from the factories to the warehouse are shown in the table below. Now, number one, we are to obtain J union A. Number two, we are to obtain K union D. And number three, we are to work on L union D. So, and also the another question. Yes, it's L union D. This is according to this solution we have. So please take note of this. So when we are talking about A union, now, first thing you need to know, our concern should be, for now, let's check our total. Let's look at the total. We have total horizontally and we have total vertically. So remember, we've talked about it. This is when we are talking about vertical, this is vertical, this is horizontal. So that is, if you add them, if you add them, add the summation here, what do you have? Then if you add it from here, vertical, and horizontally we have this 153 for J factory, and for K factory we have 91. Then we have 91, and for L we have 147. Then the total is this. So, and for warehouse A, we have 160, warehouse B, warehouse C, and warehouse D. That is, the total supply must equals to the total must be the same. Otherwise, check your table very well. Now, the first thing is the number of A. The number of set A will be, what's the total number of A here? Is 160. So what is the number of B? The number of B is 66. The number of C is 50. Then the number of D is 115. So let's take note of this. Then what is the number of J? Our J factory now. That's the warehouse we did first. The factory, the number of J factory is 153. The word that is number of K, there is 91, and the number of L is 147. So, and the question says we should look for, then if you have this from the table, we need to check at the point of intersection 2. Let's check, what do they have in common? How do they intersect? So if you look at it now, let's look at, because according to the definition we have for union sets, the union set means when you have J, number one give us, he said we should find J union A. The definition of J union A means number of A plus number of B, number of J plus number of A minus the number of J intersection A. So meaning we have number of J, we have number of A. What is the number of at the point of J intersection A? So we will solve that. So number 2 says K union D is number of K plus number of D minus number of K intersection D. Then number 3, we need to know is L union D is number of L plus number of D minus number of L intersection D. So let's define this and this and this. We need to define it. So let's go to our table. You can only define it from your table. Okay. I will pick another marker. Okay. Number of, let me just clean this so that you can see clearly. Now, we need the first thing we need now is number of J intersection A. Look at J. Where is it intersects A? J, A. What's the value? The value there is 72, meaning 72. So another one is K intersects D. That is the number. Let's look at K intersect D. Put another marker. K intersect D. Go to D. This is it. This is D. K intersects D. The value there is this. Remember, it's not K intersects A. If it's K intersects B, you pick this. If it's K intersects D, you pick this. But it's K intersect D. Okay, 22. Then number of L intersect D. L intersects D. Then this. L intersects D. L intersects D is 43. 43. So we can go ahead and solve our problem. Now that we have idea of what they ask us to do. So let's continue. So from there we can continue and solve the problem. Let me share the screen again and continue from there. Okay. So the first question says, let's start from the first question. J union A is the same thing as number of J plus number of A minus number of J intersection A. So what is number of J? We know it. 153 plus number of A is 160 minus A intersection J intersection D A is 72. If you punch your calculator very well, you have 231. So that is number figure 1. Number figure 2. K union D is the same thing as number of K plus number of D minus intersection a number of K intersection D. So which is going to be 91 plus 115 minus 22. If you punch it very well, you have 184. So number 3. So we have Roman figure 3 here to be L union D is same thing as number of L plus number of D minus number of L intersection D, which is same thing as 147 plus 115 minus 43, which is equals to 219. So you can continue from there and do the next example by yourself. It is very simple and direct with a question. So you can solve this. So quickly, we can move to Venn diagram. So we'll be talking about Venn diagram. Under the Venn diagram, what are the things we need to know? I'll give us the basic, and from there, I'll give an example. Then I'll solve this example too, although it's typographical or error is some here, but I will fix everything together so that all of us will benefit from it. So let's continue from Venn diagram. So I'll share my screen, then I'll just give us the basic things that it's useful here. And Venn diagram is used to solve the problem involving set theory. And some of the definitions, part of the definition of the Venn diagram, let me give us this. Then we'll come back to the question and look at the little things. We have what we call Venn diagram, meaning when you hear diagram, shows that there is a representation, a pictorial representation. For example, we call it, we said a Venn diagram is a pictorial representation of the relationship between between sets. Now let's look at this. We have let's check the following diagram. The following diagram show the set operators, also the set of operations and Venn diagram for complement of a set disjoint complement of a set disjoint sets then subsets intersection and union set. So now let's check the first diagram. Number one diagram we have here. The Venn diagram is represented like this. So let's say we have set A and set B. This is A, this is B. Now we now have this inside this, including this place. So what it means, then we have our universal set here. This is our universal set, the entire set. This simply means where the shaded part is called set A. Now let's look at number two. If you have this, so we have this, and we have this. So our universal set, don't forget, pick this. So look at the shaded part here. So let me just use this. Don't forget, we have our A and our B. So the shaded part shows that we call it A prime. This picture, let me shade it very well. So all the shaded region here, we call it A prime. I'm looking for a nice color that will give us a good picture. Let's try and use the yellow. It's too. So the shaded part is called A prime, that is A complement. Everything shaded is called A complement. So we have A we have B. We only do the comments to A complement. So let's look at number 3. Okay, let me write this. We call this one A complement. This is the complement of A. So we proceed from there. Number 3. Another diagram. So our A is here and our B is here. Is there anything in common? No. So we have it to be A and B are disjoint sets because nothing enter any of the set, and nothing is common to them. Number 4. Let's look at this. Using cluster sets. So we have our A here, then we have B contained in B. So we have B inside. We call it B. So this is B. The B is called B is proper. This B contain, this is contained A. B contained in A, that is subset of A. Subset of A. So proceed by saying number 5. So we have the shaded region too. The shaded region. We have A and B. So this is our universal set. Simply means both A and B, that is A intersection B. The shaded part is A intersection B. So let's take note of that. Then number 6, I will solve the question again. Then we have A, then we have A, then we have B, A, B. So everything contained in them. So the shaded parts. So this one is either A or B, that is A union B. That is, add everything together without repeating any element twice. So from here we can proceed to our given example. Let's look at the given example. Given that We have a Venn diagram with our universal set. We have A, we have B. A is here, B is also here. So then we have elements. We have 1, we have 2, we have 5. Here we have 3, we have 4, we have 6 here. Then the rest is 7, 8, 9, and 10. The question says find A. A intersection B, B. A prime union B. A prime union B. So the first thing we need to solve, let's solve A intersection B solution. A intersection B, A intersection B can be solved by, what is intersect? Remember where we talked about intersection the other time, what are the elements inside our intersection from 5? So we have 3, we have 4. Then we need A prime before we find the union. A prime. Let's look at the A complement the other time. Look at it. We define A complement here by everything in A without touching, leave everything in that circle of A. The other elements are A complement. So look at it. The other elements here is 6, 7, 8, 9, 10. Apart from circle of A. So meaning A prime union B can now be written as, we have B already. What is our B? That means we also need to get our B out. Our B only, B will be, number of B is what? Anybody? So define your B. I'll leave it for you. You define your B the way we define A. Define your B, number of B, solve it, and find the solution to this. So I'll leave that one for you. Maybe I should do it. No, you can do it by yourself. All you need to do is to find B and find the union between the two. So let's look at the question 2. In this context, we have in a Venn diagram that contains A, B, and C. We have A, B, and C. So in A we have 10. Then okay, I would need to make this one bigger so that it can contain the good number of elements that I want. 1, 3, 9. Wow. Okay, let me try and draw it neatly. We have A, we have B, we have C. A, B, and C. We have 1, 3, 9, and we have 10. We have 4. We have 2. We have 6. We have 13. We have 15. We have 14. we have 11, we have 12, we have 5, we have 7, we have 8. So you can give us the question to solve. Different question. They can ask you to find A union B, B A intersection B intersection C. So we can ask you A prime B prime and C prime. So union means addition of the two elements. Intersection means what is common to them, to the both of them, that they all share. For example, I will just jump, I will do, if I want to find the solution to B now, intersection, this is the point of intersection to the three of them. So Bini, the element there, 1, 3, and 9. So if you want to solve A, question A is simple. You want me to solve A too? Okay, let's look at it together. If you want to solve A, question A union B. I want you to solve it by yourself before. So if I say B, A intersection B, this is the point. But let's A union B, remove C and find the union. Look at the Venn diagram we drew the other time. Look at it, A union B. All the elements in A and B. Yes, we have universal sets here, no, but all the elements in A and B. All the elements in A and B. If I take the sketch out by myself, I will have this, and you have this. What is the element in A? We have, if I want to take, if you take C out of it, the remaining, okay, let's take C out. The element is C now. We have 1, 3, 9, 14, 15, 11, 12. You take them out. You take them out. So you take all the, but our target here now is A union B. Match the two together. So from then you can, 10 is there, 13 is there. What other thing? We have 4 here. What other thing? So label it and make sure you solve everything in this case now. Then find the complements and solve the complement. But let's look at the example. One of the questions in your, we have one of the questions here says, let's look at this question, the Venn diagram. It says, suppose there are 75 students. The first thing you need to know, 75 students in a class with the student offering at least one of the subjects, chemistry, physics, and biology. 34 students offer physics. 36 students offer chemistry. That is only. And 41 students offer biology. They are only. 13 students offer both chemistry, physics, and chemistry. And 14 offer physics and biology. And 15 offer both biology and chemistry. Represent the data of the Venn diagram. On a Venn diagram, find the number that offer all subjects, biology only, a subject only, or two subjects only. So for us to do that, that now leads us into the solution. So let's look at it. We have three subjects. So we have physics, represented by P. We have chemistry, represented by C. And we have biology. Okay, I think the circle needs to be bigger than this, so we have physics, we have chemistry, and we have biology. So the universal set is here, everything. So we don't know the number of people that offer the three, so which is part of intersection. Since we don't know those people that offer the three, we call them X. How many students offer both? Because according to them, so let's look at the question again. The total is 75, but from here, we have some students that offered the two subjects. So for us to solve this one, we first of all need those, before we calculate those that offer physics only, because out of people that offer physics only, the people that have three also subjects also will be there. So we can't say the actual number that has physics only now until we know the value of X. Until we know the value of our X. So we don't know the value of X yet. Let's look at it. How many? 13 offer physics and chemistry. So 13 minus X, because we don't know the number of people that offer the three together. So we need to do that. 14 offer, we have 14 for biology and physics, X. We now have 15 offer biology and chemistry. We have 15 minus X. So for us to calculate physics only, we need the value. Chemistry only, we need to know and deduct it from X, or add it to the X. Add it to X. We need to know the number of people that did this, so that we'll be able to use it to this. So the next thing we need to do is to now say that let's like we said, let's S equals to physics intersection. People that write physics intersection, chemistry intersection, biology. Let S equals to this. Then, if S equals to this, then for probability, physics, students that study physics and chemistry will be 13 minus X. Then physics and biology will be 14 minus X. So I hope I'm communicating. So then we need people that study biology intersection chemistry will be 15 minus X. So for us to now solve for physics only now, physics only, all we need to do is, what's the total number they mentioned the other time from the question? They mentioned 34. So it simply means P 34, but not only physics 34. Is a P equals to 34. At the point of physics equals to 34, now everything inside the physics will be added together. We'll now deduct it from 34. That is, will now be 34 minus, open the big bracket. Element in there is, let me draw the, we have 13 minus S. We have 14 minus S. Then we have X. These are the elements that is in physics only. So we now put it here by saying 13 minus X plus, add everything together, 14 minus S, then plus X. What do we have? When you open the bracket, you have 34. This cancel this. So we have 34 minus, let the minus open the bracket, minus 30 minus times minus 14, minus times minus plus X plus 14. So physics only will now be, let's add them together. This is, when you do the addition very well, you have 34 minus 13 plus 14. No, minus 14, sorry, because this is minus 2. The minus will have affected this, while the minus affects this one. So we have 34 minus 13 minus 14. It gives us 7. So we have our physics only will be equals to 7 plus X. So you go to physics only side, put it there. 7 plus X. So now we do the same thing to chemistry only. Chemistry only. Chemistry only, the total for chemistry only is 36. C is 36 in this case. So if C is 36, we have 36 minus everything inside the chemistry too. Let's check what are the things inside the chemistry. Minus 13 minus X, X and 15 minus X. We have 13 minus X, we have X and 15 minus X. So these are the elements inside. So we have 13 minus X plus 15 minus X plus X. So this cancels this. So we have this, open the bracket again, 36 minus 13 plus X minus 15. So at the end of the day, you have 8 plus x. So for chemistry, so we go to the circle of chemistry, 8 plus x. Remember, we are still looking for the x to be able to ascertain the number of people. Then we have biology only. Under the biology only, what we need is how many, what is our B in this case? Our B is 41. According to the question, we're given 41. So we want to know how many people in biology. We have 41. Let's draw the circle to help us. Let's draw the circle. Under the circle, let's check. We have in the B circle alone, we have 14 minus x, x, and 15 minus x. 14 minus x, we have x, and 15 minus x. So we have 41 minus, open the brackets, 14 minus x plus 15 minus x plus x. Because this one goes with this. So when you open the brackets, you have 41 minus 14 plus x minus 15. So at the end of the day, when you add everything together, you have 12. You have 12 plus x. 12 plus x. So let's go to the 12 plus x. So we have here 12 plus s. So how do we now get the x? Remember, the total value of the total number of students in that particular exam, the total value is 75. So all we need to do, equate everything in your unit, in all the subjects, add everything in the Venn diagram together, equals to 75. So how do we do that? We just said 7 plus x plus 8 plus x plus 12 plus x plus 13 minus x plus 14 minus x plus 15 minus x plus x. Everything equals to 75. So some x will go, this s cancel this s cancel this, then this s cancel this, remain one x. So if you add everything together, you have 69 plus x equals to 75. So our x will be 75 minus 69. S is equals to 6. Now that we know the value of people that did all the three together, so we can proceed from here by saying, since we can now look for x only, we can now solve the question. The first question says, the number that offer all the three subjects, the number that offer the three subjects. The number that offers the three subjects is 6, because it's s, which is equal to 6. Number 2, biology only. Is going to be 12 plus s, which is the same thing as 12 plus 6. And we know is 18. So the number 3 now says a subject only, which is contained with biology that we just did, is going to be 12 plus x, which is equal to 12 plus 6, 18. chemistry only is going to be 8 plus S, which is equals to 8 plus 6, which is 14. Physics only which is equals to 7 plus S, which is 7 plus 6, which is 13. Question 4 says, two subjects only. Two subjects only will be physics and chemistry. We know them. Physics and chemistry is 13 minus X, which is going to be 13 minus 6 equals to 7. Then physics and biology. Physics and biology is 14 minus S is equals to 14 minus 6 equals to 8. Chemistry and biology. Chemistry and biology is 15 minus S equals to 15 minus 6 is equals to 9. So when you add the total, it will be 24. So I believe we have done the justice to some of the questions that might be giving you a problem, especially when it comes to set theory. So in case you have any other question, please leave comments on my YouTube channel, ask questions, send a mail to me, and from then I will attend to it, and yes, I'm sure everything will be sorted. So on this note, I'll call it a day. Thank you for watching. Thank you for listening. See you next class. Bye.